graph. So if you look at the graph, I'm not sure how it happened, but it did happen. They're supposed to be at integer values, so this all got shifted up a little bit. So that's supposed to be at 4, 0 exactly. This is supposed to be at 6, -2 exactly. And this is at 10, 0 exactly. This is perfectly a semicircle. And on the AP, it'll be very, very clear. I will also tell you that you should be able to do the rest of it given that information. All right, so I'm going to just darken that in so it looks a little nicer. Okay? We good? All right, so based off of yesterday, if you see this statement, we know that it's a true statement, but then what do I want to do to both sides of the equation? When you see the constant to x. Take the derivative. So when I do that, I'll have a second statement that the derivative of s is equal to, drop that in, and you get f of x. So the graph says it's f of x. That's the same thing as s prime of x, which happens to also be the same thing as velocity. So I'm actually looking at the velocity graph. All right, so this is the graph of velocity, and once you know that, it makes it a lot easier. All right, so s sub 2, it means we're going to use the definition, and it says find the integral from 2 to 2, which obviously is 0. I'm going to put that in there just so you have kind of notes. Don't do that for real, though. Obviously, it's not proper notation, but just so that you have something to give yourself a hint. So I want to do now from 2 until 0. What's wrong with that? Lower limits on top, so let's flip that bad boy. 0 to 2. And so I'm going from 0 to 2. 0 to 2 happens to be a quarter of a circle with a radius of 2. So, quarter of the circle with a radius of 2 ends up with pi. So the answer to this guy becomes negative pi. It looks like it's supposed to be positive, but remember we're going backwards, which is where that negative comes from. All right? And then s sub 6 goes from 2 until 6. So 2 until 6 says, I'm going to use that quarter circle that we just found the area for, but it's positive this time because we're going forward from 2 until 4. And then I'm going to use from 4 to 6. That's a triangle with a base of 2 and a height of 2. Therefore, that is negative because that triangle is underneath the x-axis. So that's where that -2 comes from. You got to remember that the integral is a net signed area, not just a plain old area. Josh?
Why is there 2?
Because I told you to. Okay. All right. Velocity. So I have the velocity graph, and I want to find velocity. What should I be looking at? The y values. Makes it easy. Now I'm just going to go straight across and do y values. V of 2, the y value is 2. V of 0, the y value is 0. V of 6, the y value is -2. So that should have been pretty easy. I have velocity's graph, but now I want to get to acceleration. How do I go from velocity to acceleration? Slope. So I'm going to look at slopes now. So I'm going to keep saying the word slope. The slope at 2 is how much? 0. This one's a little tricky. The slope at 0 is undefined. What kind of undefined is there? Vertical tangent. Beautiful. And then A of 6. Whoop, whoop. Corner, so it's undefined also. There was an AP question that had a graph that had a vertical tangent in it from a semicircle, and most people got a lot of that problem wrong because their sign chart was missing an extra value. So you want to make sure you think about your undefineds. We good there? All right, so then I'm going to steal the graph and then take it over to the next page. You guys can move on and see what you can do. Actually, no, I don't want to copy that. Let's erase this. I am recording. I do. And I remembered to turn on the mics this time. Get that out of the way. All right. So what are you guys thinking about for number 2? Particle moving. So I'm going to say it backwards from what you said. The velocity, which happens to be the graph. So we know for this question we need the velocity. This is the graph of velocity, so I'm going to need velocity sign chart. Since it is the graph, I'm looking at y values, which we already discussed a second ago. My y value is 0 at 0, my y value is 0 at 4, and my y value is 0 at 10. My y values are positive, and then my y values are negative after 4. Now I can answer those questions easily. We're going up, so in this case I'm telling you that it's vertical motion, from 0 until 4 because v of t is greater than 0. Down from 4 until 10 because v of t is less than 0. And then not moving at 3 different times because v of t equals 0. Your reasons are exactly what you use to find the answer anyway, so you're just rewriting that. All right, when is a particle's acceleration positive? So how do I get from velocity to acceleration? Slope. So I want to look at the slope. So when is the slope? All right, so let's do sign chart. 10, 0, I want slopes. So the slope is 0 at time equal to 2, because we already did that. The slope is undefined. We found at 0. It was undefined at 6 because it was a corner, and then again at 4 because it is a corner. Okay. The slope is positive from 0 to 2. The slope is negative from 2 to 4. The slope is still negative from 4 to 6, and then the slope is positive from 6 to 4. Are there any questions on that part? Okay. Joshua, I asked for questions, not comments. No problem. All right. Positive is at 0 to 2, and then again 6 to 10. Slope is positive. I use slope. That's usually how I just do my answer. When does the particle change direction? Changing direction, you should be looking at the velocity sign chart. So all of this is stuff from chapter 3. We did it over and over and over again in chapter 3. The only time it changes position is at time equal to 4. If you think the definition is when it's equal to 0, it's incorrect. It's when the velocity is equal to 0. Or undefined, and velocity changes sign. So you can actually put that change from positive to negative. I don't really care, because in this case, you don't care which way it changes. It can go minus to plus. Any questions straight through? Are we alive? I don't know. All right. Look at the next set. All right. I want you to set up number 5 and 6. I want you to do the setup that I always tell you guys to do. All right. So maximum position. What do I ask you guys to do first? Max. Oopsie. Get this thing working here. Max. Position is S. We do that so that now I know I'm going to need S prime's sign chart. Who's S prime? Velocity, which we already have, right? That velocity sign chart was 0 to 10, and then, what was the number? 4. And then it was plus to minus. Is that correct? Yeah, and these are 0 also. Is that correct? Okay. So maximum position happens at 4. So when is time equal to 4? Where does it occur means how high is it. So that would mean that not only do I need the 4, I also need to know the integral from 2 to 4. And in this case, that's the same thing as me finding the area, net signed area, from 2 to 4, which I believe we already did. That was pi. Is that correct? It was the right half of the circle, or sorry, right half of the semicircle. When and where does the minimum position occur? So the minimum position possibles are the endpoints. Don't forget about your endpoints. So my possible is S sub 0. My other possible is S sub 10. S sub 0 we already found. I believe that was negative pi. Is that correct? Okay. S sub 10 we did not find, but we can do that pretty quickly. S sub 10 would be from 2 until 10. So quarter circle, nice big old triangle with a base of 6 and a height of 2. So integral from 2 to 10 would be quarter circle, which we already know is pi. That triangle is below the x-axis, so what do I have to do with that? You're going to subtract that area. So 1/2. The base was 6, the height was 2, so 6. So, who's smaller? No calculator. S sub 0. Because this is about negative 3.14, and positive 3.14 minus 6 will get you a little bit bigger than that. Okay? All right. Any questions on those? All right. Last two, which you got from 5.3. I would like you to write down what you think the formula should be for number 7 and number 8. All right. So whose graph do we have? All right. So and let me write that down. We have V of t. They want the average of V of t. These are the same. So what does that mean? You want y values, which means you use the average. Which one? Slope or value? Value. Things that you should know about the average value formula. If I want the average value, how you'll be able to tell is based on the function you're given. It's the same as the average that you're finding. So I'm given velocity, and I want to find the average velocity. They're exactly the same function. Other things you should know. Whatever unit this is right here, when you're all done this calculation, the units become the same. So if I want to find the average gallons per minute, or the average rate that water flows out of a cone, then my answer will be a y value on that graph, and it will be the same exact units as what it's asking me for. It should make sense. When you guys get into calculus, you lose all common sense. Common sense says, if I want an average velocity, I better get a velocity. And you only get that by doing the value formula. I'll tell you why that works. Remember, to find the units of an integral, we take the y unit, multiply it by the x unit. So y times x. What units are these, x or y? Those are x units. So what happens to the x divided by x unit? They cancel. So the dt, which is an x unit, cancels with the 10 minus 4, which is an x unit, leaving you the y unit. Why do I say that? Because I've seen multiple AP free response questions where they ask you for the units and you get points for that, but the problem was not a simple velocity problem. It was not a simple gallons per minute problem. It was something having to do with blood flow, or it had to do with some weird shape that when you read it doesn't really make sense. So you have to understand your units. Everyone forgets about this part of it. You're doing 1 over b minus a. B minus a are x units. So x unit, they're going to cancel, leaving you back with the y unit. Extremely important to know. It's easy to do. So that's why we use that formula. Average acceleration. I have velocity. I want to get to acceleration. How do I get there? One word answer. Slope. That's how you know that you're going to have to use the slope formula. So and listen to what I say. The slope of velocity is acceleration. How do you find slope? The slope of velocity is acceleration. So the slope of velocity, this is the slope formula, gives you an acceleration. That is the reason why I use the slope formula. More than half of you got these flipped. And if you don't understand the reason why you use them, you're just going to keep flipping them. So you want to make sure you understand based on what you're given, that's how you can tell which one to use. There is another method. If I gave you the function, if you can find the acceleration function, then you can use average value for both of them. It does work. But I like to always base it off of what I got. All right, so with that said, In this case, I'm going to change the b and a to numbers. I believe the numbers were 10 minus 4 all over 10 minus 4. That doesn't say 4. Notice I do that a lot. I say a number and I don't write it. All right. So this guy, what do we get? 1 over 6. The integral from 4 to 10. Did we find that? It was negative 6, correct? Negative 6 because it's a triangle underneath, so it's negative 1. All right. Find the average acceleration. V of 10 was 0. V of 4 was 0 over 6, so the answer is 0. All right. I'm just trying to combine what you learned from chapters 3 and 4, mix them in with what you're learning now. That's why 5.4 is so hefty, because they do things like this where you mix everything now. All right. On the next page is a free response question. We're going to end class with you guys working together to finish that off. So go ahead into miniature groups. You have about 9 minutes to work on that. I want you to work together just to make sure that your answers do match. Okay, it should be very similar to the one that we did. All right, get yourself into groups, please. Yes.